Inverse cosine function. So this is going to start looking familiar because the setup to find that inverse cosine function is going to be very similar to how we found the inverse sine function. So sadly, the cosine function is not one-to-one either, but we can restrict its domain to where we still get that full range, but the function does not repeat output values. Again, there are lots of intervals where this can happen because the original domain of the cosine function is all real numbers. But mathematicians, got together one night and they said, okay, let's make that interval 0 to pi. It includes the origin, it reaches everybody, and I get that full range from -1 to 1. But if I go any farther to the left or right, I start repeating output values, and I don't want that. So I'm going to restrict the domain to 0 pi. So with the restriction on cosine, domain is 0 to pi. So I'm just looking at that interval, and the range is still -1 to 1. Now, because inverse functions switch inputs and outputs of the original function, they also switch the domain and range. So the domain and range of that inverse cosine function, again, if the domain of cosine restricted is 0 to pi, then that is the range for inverse cosine. And if the range, of course, of cosine is not restricted, right? It's just -1 to 1. That is the domain of the inverse cosine function. So what does the inverse cosine function do? It takes a cosine value and returns an angle, right? That produces that value, but that lives in the range 0 to pi. And that way we only get out one angle and it's still a function. So the cosine inverse, we can see the graph here, we can think of as y equals cosine inverse of x. So you'll see it written like that, but we'll also see it as arc cosine, again, to just both our representations of the inverse cosine function. So let's evaluate this expression or state it's undefined and do this without the use of a calculator. So if I have the cosine inverse of -1/2, this is going to say at what angle between, I'll say, 0 and pi does cosine produce a value of -1/2. Okay? Well, guess what I'm going to need? The old unit circle. And I got to call attention. I go, well, where am I living now? 0 to pi is where inverse cosine can produce outputs. Okay, so where does my cosine have an output of -1/2? Well, that happens here at 2 pi over 3. I can double check that. I have -1/2 comma root 3 over 2. And so I can see that the cosine inverse of -1/2 is equal to the angle 2 pi over 3, because cosine of 2 pi over 3 is equal to -1/2, and 2 pi over 3 is within the 0 to pi range of the cosine inverse function. Okay, now let's look at arc cosine of 1. So this is the same question, except when does cosine produce a value of 1? And so I'm going to look at my unit circle. And again, I'm only allowed to look 0 to pi. And I say, does cosine have an output value of 1? And I say, yes, it definitely does. That happens right here at 0 radians, right? Because at that place I have 0, I have 1 0 for my point, 1 0. And so the output here is going to be 0 radians, because this angle here has a measure of 0 radians, and when I do cosine of 0, I get an output of 1, and 0 is in the interval 0 to pi. So let's look at when I want to evaluate expressions involving composition of cosine and inverse cosine. So it's very similar to sine, where we have some issues, but we can work around some of them and not others. So let's take case 1. Cosine inverse is the outside function. Cosine is the inverse function. And again, what I'm going to be given are like just this, cosine inverse of cosine of x. And I'm saying, okay, what's that going to be? Where x will be some value, right? It's an angle. And so what we say is that this whole thing is just equal to that input x if or when x is in the interval 0 to pi. Okay, so I can take cosine of any angle I know, but if I take cosine of the angle between 0 and pi, cosine inverse can return angles only in between 0 and pi. And so this x has to start out between 0 and pi if I want them to match. So if I look at that input angle and I go, that's between 0 and pi, I automatically know there's no work to be done, and I know what the answer is going to be. So I'm all set. Now, if this is not the case, I can still find the answer, but with some extra work. Okay. What about if cosine is on the outside? Well, cosine inverse can only have inputs when x is in negative 1 to 1, right? It's only defined. And so if cosine inverse is undefined, the whole thing stops. So cosine inverse only accepts inputs that are between negative 1 and 1, and then cosine is going to act on that and then return something back between negative 1 and 1. So these just automatically have to match. It's so nice. And if not, then it's just undefined because cosine inverse wouldn't even be able to act on that initial input. So let's look at this example. Evaluate the expression or state that it is undefined. Do this without the use of a calculator. Okay, so this is case 1. Just saying like case 1, where the input angle is between 0 and pi. 5 pi over 7 is in between 0 and pi. So in this case, when that happens, we get that the whole thing is just equal to the input angle. And then you're just done. What about part B? Cosine inverse of negative 0.3. Now we're in case 2 where cosine is the outside function. So I look at this input. The input of this composition is negative 0.3. Is that between negative 1 and 1? It is, so this is just equal to negative 0.3. Okay. Now we want to look at these kind of trickier ones, right? Let's look at ones that require those extra steps, that extra work, and see how to do that. Okay. So the best case scenario, or the second best case scenario, I should say, is if I have an angle where that is the input that can be found on the unit circle. Okay, so I'm getting a little ahead of myself. I'll read the instructions. Evaluate the expression or state it as undefined. Do this without the use of a calculator. All right, so negative 5 pi over 3, so I have a few notes. So first note, negative 5 pi over 3, is not in 0 to pi. Okay, so that's kind of my first note. So this is my sad case. That's why I have more work to do. But what I do see is negative 5 pi over 3 is on unit circle. That's good. Because now I can just do this by doing cosine of negative 5 pi over 3 and actually finding out what this value is. So I'm actually going to be able to determine this value. Actually determine this value. By this value, I'm talking about cosine of negative 5 pi over 3. Okay, so let's take a look. So I have, boom, drawing my unit circle. I'm going, where's negative 5 pi over 3? Well, I got to start at the good old positive x-axis, but I have to go backwards, okay? And I know if I go all the way around, I get negative 2 pi or negative 6 pi over 3. I need to stop 1 pi over 3 short. So this would be negative 5 pi over 3. And again, if that still feels like a little rough, like how do we do that? Draw in those pi over 3s, right? Like cut it up into 6 total pieces. So each pi is a half rotation. So this would be like pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3. And because I have to get there going counterclockwise, I end up with a negative angle. So negative 5 pi over 3. Okay, so what am I doing there? So now I have some point, right? When I arrive, that intersects the unit circle. And this one is 1/2 root 3 over 2. And so what I can see is that cosine of negative 5 pi over 3 is equal to that x-coordinate, so 1/2. So let's bring back what I'm doing here in the first place. I started with cosine inverse of cosine of negative 5 pi over 3. And I said that is equal to cosine inverse of 1/2. And I go, okay, well, where does cosine inverse equal 1/2 between 0 and pi, right? This has to be equal to an angle between 0 and pi because of the range of cosine inverse. So where does cosine, so So this is really asking, where does cosine have output of 1/2? Reminder, must be in 0 to pi. Okay, well, we say at this angle, right? But we can't call it negative 5 pi over 3 because that's not in between 0 and pi. So instead, I can just call it pi over 3. And so this is equal to pi over 3 because cosine inverse of 1/2 is equal to pi over 3. So here I just kind of did it in steps, right? I was actually able to find the value of that inside function cosine of negative 5 pi over 3, and then this output becomes the input for cosine inverse, and then I'm able to find the angle where cosine is equal to 1/2 that occurs in 0 pi. All right, let's look at part B. What is cosine inverse of cosine of 13 pi over 7? Okay, well, 13 pi over 7 is not, so like a couple notes. So note 1. 13 pi over 7 is not in 0 to pi, right? I know that because 0 would be like 0 pi over 7 and pi would be like 7 pi over 7. And so it's not in there. And 13 pi over 7 is not on the unit circle. It is, right? Of course, every angle is on the unit circle, but it's not one of those like kind of nice ones that I can go find where it lives. It's not really coterminal to a nice one where I know where it lives. So we have to kind of go to, you need reference angles, and I can certainly do that. So I'm going to need a picture for sure. So first, what I need to do is find where does 13 pi over 7 live? I go, well, I don't know. But what I just said was like, if this is 0, this is 7 pi over 7 on the negative x-axis, right? All the way around again then would be 14 pi over 7. And if I'm 13 pi over 7, right, I'm going to be just shy of that. If you're really worried and you want to check, half of 7 is 3.5. So this would be 10.5 pi over 7. 13 pi over 7 is more than 10.5 pi over 7, but less than 14 pi over 7. So I'm feeling pretty confident that I can just draw that in there. Okay, so here's where 13 pi over 7 will land. But again, it starts in that initial side on the positive x-axis, and I'm just going to draw it in. So here's 13 pi over 7. Now, I am after cosine of 13 pi over 7 is some value. I'm never going to find out what that value is in this problem, but I don't need to. It is some value. Do I know some information about that value without actually knowing the value itself? I do. That value is going to be equal to, since it's cosine of this angle, the x-coordinate at this point. I don't care what the y-coordinate is, right? It's the x-coordinate at that point. So I have cosine of 13 pi over 7 is equal to some value, okay? And then we give that to cosine inverse. We're like, hey, sorry, all I have is that it's equal to some value. It's like, okay, great. But I know it's the x-coordinate at this point, and that's enough of a clue, okay? And so really what I'm asking is, where in the range 0 to pi does cosine take on that same value, right? Cosine has inputs and outputs. So we're saying, for which input in 0 to pi does cosine have that same output value? So what we're really asking is, what angle in between 0 and pi, right, has a terminal side that intersects the unit circle and has that same x-coordinate? Okay, what would that be? Well, it would just be kind of somewhere up here, right? It would be in that first quadrant, just reflected over. So I'm going to draw in that angle because that's my goal. That's where I want to get, right? So I think if I can get this angle here, then I've got it. Well, then I have to figure out what I end up finding in all of this. Sometimes you can kind of do it by eye, and maybe you wouldn't necessarily call it the reference angle. You could do it without calling it that, but that's what this is. It's a use of a reference angle. So here's my reference angle for 14 pi over 7. It's this piece in here, right? It's that little piece in between the terminal side and the positive x-axis. And it has a measurement of just pi over 7. So I'm going to say 13 pi over 7 has a reference angle of pi over 7, okay? Then because it's a reference angle, what's nice about this is when I reflect that reference angle over, okay, then it's going to hit at that spot that has the same x-coordinate. So let's think about where we are. Here's this reference angle down here that I just kind of filled in. If I reflect that reference angle over and kind of draw it now going up from the positive x-axis, and then think about where that's going to hit, okay, that's really what I'm doing. So if this is pi over 7, right, this is like kind of this opening of the reference angle is pi over 7, and I then put that up here on the positive x-axis, then that is going to be the answer to my problem. So cosine inverse of 13 pi over 7 is just equal to pi over 7. So think about what we did. We said, what is cosine of 13 pi over 7? We said, I have no idea, but it's equal to the x-coordinate on the unit circle. That is a big deal. So we say, okay, it's this x-coordinate where the terminal side of 13 pi over 7 intersects the unit circle. And then I say, okay, well then I hand it over to cosine inverse. I say, cosine inverse is really saying, at what angle between 0 and pi do we get same cosine value? Well, we get the same cosine value where we have the same x-coordinate. So the points have to really be on top of each other. And we say, that just happens up here. We just reflect it up here. And we go, okay, well, what angle is that? And we go, well, it's a little tricky, but we just, it's kind of what's left, right? We go 13 pi over 7. To get all the way up would be another pi over 7. And then instead of going down to 13 pi over 7, we have to go up, right, to find our angle pi over 7 in quadrant 1. All right, let's look at the last example. Cosine inverse of cosine of 4. So when we're looking at that, we say 4 radians, not on the unit circle and not between 0 and pi, right? 0 and pi is about 0 to about 3.14 radians. So 4 is not in between 0 and pi, and it's not 4 radians. It's not like somewhere on our unit circle, something nice. So we have to do the same kind of drawing action again. Okay, and I want to draw where 4 radians is. Well, 4 radians is going to be in quadrant 3. I'll just draw it like somewhere like that. Again, the quadrant is the most important part, and I'm going to draw it in standard. Here we go. So I get 4 radians. So standard position there, 4 radians. And now I have to go, okay, what's cosine of 4? So what I really want to do here is draw in a unit circle to kind of help us. All right. So there's a little wonky unit circle. But the point is, I know that because this is cosine, the x value at this point is going to be equal to this cosine of 4, right? Cosine of 4 is equal to that x coordinate. So this is cosine of 4 is some value. I don't know what it is, but it is that x value there. Okay. So what this is, and we could even say that. So as long as we introduce the value of x, so we define it somehow, we say, it is the x-coordinate of the point on the terminal side that intersects the unit circle. We could even say, well, then this is cosine inverse of x, right? Because we've just said that cosine of 4 is equal to x. All right, well, what's that, right? Well, we say cosine inverse can only have outputs between 0 and pi, and it needs to be an angle, right? Cosine has outputs between 0 and pi that are angles, okay? And it needs to be an angle such that when I take the cosine of it, right, it has the same output. Well, that means that the terminal side needs to have an intersection point with that same x coordinate. Okay, so that's really what I need. So what I need is an angle that has the same x-coordinate at its intersection point, but it needs to be between 0 and pi. That's this point here. So its terminal side would be going right through that point in quadrant 2 with its initial side on the positive x-axis. Okay, so this angle here that I just drew in here in kind of this pinkish red, I'll call it theta, I can call it whatever I want. That angle, right, is our answer. Okay. So what angle is that? And I go, I don't know. Well, this is where we get to kind of solve a little puzzle. It's so cute. Okay, so how can I do that? Well, the best way that we can do that is with a reference angle. Okay, so what I'm going to do is draw in the reference angle of my original angle 4 radians. So 4 radians is this angle right here. Its reference angle is formed by its terminal side and the closest part of the x-axis. So what I'm going to do is just shade this in. So this is the size of the reference angle. Okay, what would its measure be? So reference angle of 4 radians is, well, let's see. 4 is the measure of this whole angle. Pi is part of it, and then the reference angle is the other part of it. So whole is 4. Okay, so on the side here, I have 4 is pi plus the reference angle. So we'll call it t prime. Okay, so t prime is equal to 4 minus pi. So 4 minus pi is the reference angle of 4 radians. Okay, so now what I can see is because that part is the part that's being reflected, right? Like that's how I found the angle that I'm after. Is I'm really taking this part. If I reflect this angle like up here, we're basically just saying that this opening here is the same as this opening here. Okay, so if those openings are the same, well, that seems like that's good. So we have another piece to the puzzle. So what I can see then is that I'm running out of colors here. This part here, right? This opening is also t prime. Well, what I care about is this angle theta, right? That's what I'm after. That's what I'm trying to find this whole thing. So what I need is that it looks like pi plus t prime is just equal to, theta plus t prime is equal to pi. So how do we know that? Here's theta, here's t prime. That both of those angles put together, right, make the angle pi. Okay, well, I'm trying to find theta. Theta is just pi minus t prime. Okay, that seems good. But I need t prime. I already know t prime. It's 4 minus pi. That gives me pi minus 4 plus pi, which is 2 pi minus 4. So cosine inverse of cosine of 4 is equal to 2 pi minus 4. So a quick little walkthrough of what we did, because that was a lot going on there. Cosine inverse of cosine of 4. We said, what is cosine of 4? Well, it's the x-coordinate of the point on the terminal side of the angle 4 radians, right, where it intersects the unit circle. So I went ahead and found that point, and I said, I'm going to call that x-coordinate x. I could call it something else like b or whatever to keep track of it, but I'm just going to call it x. Knowing that I am calling it something, that's what I'm taking cosine inverse of. So I say, well, that's equal to cosine inverse of x. Okay. So we're really saying, okay, is there an angle in between 0 and pi with the same cosine value? And we go, yeah, it would have to have the same x-coordinate, so it would have to be on top of itself, okay? To be on top of each other. So we say, well, where is that located? Well, I can draw it a lot easier than I can find its value. So what I do is I take that reference angle and find its size, and I know that that's the part that's being reflected above the x-axis. And then I can use the size of the reference angle then to find the angle that I'm really after, which in this case we just called theta as kind of a placeholder, because I can see that theta is just pi take away the size of that reference angle.